start with the question, arrival of the general. So this question basically states that there are n squad soldiers, okay, and they are standing in order of non-increasing order. Okay, so the soldiers are standing in a non-increasing order of their height. But here's a thing, that the general which tells the soldiers to stand in a particular non-increasing order is short-sighted, and he thinks that soldiers are lined up correctly if the first soldier in the line has the maximum height and the last soldier in the line has the minimum height. Okay, so question is basically, it's simple, that it's saying that the first position, the 0th position in an array, if we are considering, should be of the maximum height. Okay, so 0th position should be of the maximum height, while the n minus 1th position should be of the minimum height, because the soldier is short-sighted and he sees this order as the correct order. So that's what the question is saying, what we have to do in this question. Okay, so please note that the way other soldiers are positioned does not matter, including the case when there are several soldiers whose height is maximum or minimum. Only the heights of the first and the last soldiers are important. Okay, so let's see the example. It's 4 3 4 2 1 1. So 4 is the maximum height and it's at the first position, and 1 is the minimum height, it's at the last position. It doesn't matter in between what other elements are present, only these two things matter. Okay, so this is the correct sequence, while this is not, because the minimum element is here in the middle. Okay, so in 1 second the colonel can swap any two neighboring soldiers, so we have to help him count the minimum time needed to form a lineup which the general will consider correct. Okay, so what we have to do is we have to calculate the minimum time in which we can swap the maximum and the minimum soldier so that they reach their correct positions. Okay, so one swap takes 1 second of time. Okay, so basically we can calculate the number of swaps, the minimum number of swaps required, and as 1 second is needed for one swap, that means that the minimum number of swaps is equals to the minimum number of time, right? So let's see the first test case for calculating that. So n is equals to 4 here, and so we have the soldier's height 1 2 3 and 4. We have here 33 44 11 and 22. Okay, this is the 0th position, first position, second and third. So this is the maximum height and we need to swap it to make it to the front, and this is the minimum height and we need to make it to the last. So how many swaps are we going to need? Let's see one by one. Let's shift the max element first. So when we shift the max element, here we need only one swap, so 44 will come here, and here is 33, so its position becomes 0 and 1. This is 11. Set the second position, the position doesn't change, and 22 is here, its position also remains the same. So we needed one swap. So can we say that the position of the maximum element is also the number of swaps needed by that element in order to come to the front, right? So max index is equals to 1 is equals to swaps needed by max height soldier. Okay, so this is the first thing. Now we have to calculate the swaps needed by the minimum element. Okay, so for it to come here we need to swap the positions, and we'll get the array as 44, the position remains same. 33, the position remains same. 22 comes here, its position changes and it becomes 3, and 11 goes here at the last element and its position changes. So how many swaps did we need? We needed 1 swap. So can we say that the swaps needed by the minimum element is it's 2 and it's 3, right? Yes. So swaps needed is equal to length of the array, which is 4, minus 1, which is equals to 3 in this case, 4 minus 1, minus the position of the min element, which in this case was 2. So when we do 3 minus 2, we get 1. So 1 swap was needed, right? So total time is equals to swaps, total swaps, which is equals to 1 plus 1 here, that is equals to 2. So the output we get is 2. Okay, so here we understood two things, that the index of the maximum element is equals to the swaps needed by that element, and n minus 1 minus I is the swaps needed by the minimum element, where I is the index of the minimum element. Now let's see the next test case, which is very important in Codeforces. It's an observation that I have made, that we need to compute all the test cases, because they tell you if you're doing something wrong or that there's a case that you need to keep in mind. Okay, so let's see the next test case. We have 7 soldiers here and the heights are 10, 10, 58, and we have 31, we have 63, we have 40, and we have 76. 0, 1, 2, 3, 4, 5. and 6. Now we need to get the index of the minimum and the maximum element. Okay, so for the maximum element, which is the maximum element here, it is 76, which is at the 6th position. So max index is 6 here, right? And for the maximum index, if for suppose there were 276s here, we would take the one which is closer to 0, because we have to shift it to the first 0th position. So which index is closer? It's 5. So that will give us the minimum amount of swaps needed, that is minimum amount of time ultimately. So we would have taken this, but in this test case we will take the position number 6. Okay, so when we are going to swap this to the front, the array will become 76, 10, 10, 58, 31, 63, 40 and 76. No, 76 not. It will be 40. 0, 1, 2, 3, 4, 5 and 6. Okay, so now here you can see that the position of 10 here, which is the minimum element, has shifted, right? So if we would have taken the minimum index at once after we have taken this, so we would have taken it to be 1, but as we would shift 76 to the 0th position, the array would turn to this. Now the minimum index would become 2. And why 2? Because we have to shift it here to the last position. So if we took the smaller one, it would not be the minimum amount of swaps. So as this one is closer to the last element, last position, we take this, right? So in this case, the index of the maximum element was greater than the index of the minimum element. So the minimum index increased by 1, right? So this is the thing we have to keep in mind while implementing the solution. In this case, the swaps needed for the maximum element would remain the same, but the swaps needed by the minimum index, it would decrease by 1, right? Because it's 6 minus 2, right? So n minus 1, it would be 6, as n is 7 minus 1, and we would decrease I plus 1, because the position will increase by 1 when the maximum index is greater than the minimum index, right? So the formula would then become this. Okay, so that's how we will calculate it. So when we put the values, I is 1 here it is 1, and we will add 1 to it, because after the swap it will become 2. So it's 7 minus 1, it's 6, and 6 minus 2, it's 4. So when we add the maximum index, that is 6, plus this calculated value 4, we get 10 swaps, right, which is ultimately the output. So now let's see the code for this question. So initially the minimum index is 0, the maximum index is also 0. While entering, we check if a of minimum index is greater than or equal to the current element. Minimum index is equals to I. Why equal to we have put? Because we have to get the maximum index where the minimum element is present. Okay, and for the maximum index we only check if it is a of max index is less than the current element, because we have to take the first index which is closer to 0, right? So we take it, we calculate the moves, right, which is a max index for the maximum element, and it's n minus 1 minus min index for the minimum element. And if min index is less than max index, we decrease it by 1, because the minimum index will increase by 1 as we shift the max element, right, and we output it. So that's the code for the question. I hope you understood the solution. Thank you.